I have another example of an experiment that would fit very nicely into our chapter. The topic in this section of our chapter is percent composition. If you guys were here, you would be doing this for yourselves. It's one I think is kind of fun. I'm going to start off by showing you I have a balance here. It's turned on. It's registering zeros right now. I'm going to place a pan on, and then I'm going to tare the balance to bring it back to zero. So the weight of our pan is in effect subtracted out by the scale. Now, what's the experiment about? Well, I happen to have one of the substances that we were going to use. Let me bring it into the picture here. And had you been in my classroom at this point, you would have each gotten a sample of this, and the thing that you were going to do was to open it up, weigh it, and then start to chew it. So I'm going to start to do that. I'm going to take a piece of the bubble gum, unwrap it. My package just was open moments ago. I'm going to place that into the pan and get its mass. And the reading that I have, let me bring this up a little bit for you, is a piece of gum on this initial weight is 6.54. So I'll put that on the board, and in the meantime, I'll pop it into my mouth and start to chew. A little hard. It'll take a minute or two to soften up a little bit. Now, I'm going to stop the video at this point because this is going to take me a little while to get softened and then eventually chew it. And then I'll come back and show you the next phase of it. So the chewing process is finished. I now have my piece of gum. I've taken it out of my mouth. It's had a chance to dry for a little bit. And what we're going to do is we're going to remass it on the balance. I'll just drop it into the pan. And remember, I pre-tared the pan, so it was reading 0. And now my new value is 1.73. So let me put that on the board. 1.73 grams. I'm going to label these now. This was my starting mass of the gum, so I'll refer to this as the initial mass. And now this is the final mass. And I can take these two numbers and subtract them. Okay, 5 from 4, 9, 7 from 4, 7, 1 from 5, 4. So I get a difference now of 4.75 grams. What does that represent? Well, if you think about it, while I was chewing, there was a nice sweet flavor in my mouth, and that's the coating and the additions that they put into the gum. So that's pretty much sugar products. So I'll list them here as sugars. And when I look at the label, I can see the various kinds of sugars that they use. Now I can take this, and from the calculations that I have, I can figure out the percent of sugar that's in the gum. With this number now, let me put that into the equation. Let me go back up here to the board. I'm going to take the mass of the sugar, 4.75 grams sugar. I'm going to put it over the total mass, which is the initial mass of the gum. That was 6.54 grams. That's the gum itself when you buy it. I'm going to divide, and then to turn it into a percent, I'm going to multiply by 100. So when I do the math on this, it'll give me the percentage of sugar that's in the gum. So let me put that on my calculator. I have 4.75. I'm going to divide by 6.54, and I get 72.6%. So the gum, surprisingly, has a lot of sugar in it. This would be the percent of sugar that's in the sample that I have. So when I buy a bag of gum, and it feels pretty heavy, when I buy that, a lot of the weight is just the sugar, the content of sugar that's in it. Now, I'll stop here, and then we'll start to look at how we can use this same example to do a calculation of percent for elements in compounds. Let me just stop here for a moment. So continuing, I want to point out a little error that I had in the video. This should be percent. I think you just moments ago saw it listed as grams, but just change it in your notes. The next illustration I want to give you is an example using an actual compound. I've picked up nitric acid from our lab supply, and I want to do the calculation for that, and I'll show you what I mean by that. I'm going to swing this around for just a moment. I took and brought over a bottle of our nitric acid. This is highly concentrated, and were I to happen to use this and pour it out, I would definitely wear my safety glasses and perhaps even some gloves, because this is very strong. It's listed as 15 molar, and so if you were to get it on your hands, it would cause some pretty severe burns. And it's a very important acid for production of our economy, particularly with regard to explosives and fertilizers. That particular aspect of it makes it very important for agriculture and for construction. Now, here was my piece of gum, and if you were in the lab, I would have asked you to simply, when you're finished, because it doesn't taste like much anymore, just wrap it up and toss it out. So let me do that, and we'll dispose of that. Now, for our calculation up here, what I'd like to do is figure out what's the percent of nitrogen in the compound. That's what I'm aiming to get. So what I'm going to do is I'm going to take a little equation, very simple one, and this is one you want to mark down. I'm going to take the mass of my element, and I'm going to put it over the compound mass. Mass of my compound. And then eventually I'll divide and multiply by 100, and that will eventually give me my percent. So let's put some numbers into our equation. I'll leave this sit here because you can make a comparison between the two. I'll go over to the left here and put my numbers in. In order to do this part, I have to use my periodic table. So I grab that, I have my calculator, and what I'm going to do is place the element symbol in here and then put its mass value in. So I'm going to put nitrogen over top of nitric acid, HNO3. And then I'm going to look up the masses of these. Nitrogen is 14.080 grams. That's my nitrogen. And then I look up the mass of HNO3, and in order to do that, I will do something that you've seen before. 1 times hydrogen, 1 times nitrogen, and 3 times oxygen. And what we'll do is we'll look on the periodic table to see what these values are. Let me get this a little closer for you. Hydrogen is 1.008. I'll multiply that by 1 gram, and it gives me 1.008 grams. 1 times nitrogen would be 1 times 14.080, and that carries right through to 14.080 grams. And then I have 3 oxygens, so I'll multiply 3 times the mass of oxygen from the table. That's 15.999 grams, and that will give me a total, when I put them all together, of 47.997 grams. Final step, I'll add them together. I did that just a couple moments ago, and I got a total of 63.085 grams. I'll come back over, I'll take this number, which is the mass of my nitric acid, and I'll put it down in the bottom of my equation here. So 63.085 grams, that's for my HNO3. I've put my element over top of the compound. Let me just erase this for a second now, and we'll put our answer in. I have to multiply by 100 in order to change the decimal value into a percentage. And when I did that a little bit ago on my calculator, I've gotten 22.32% nitrogen. So the process of doing this is not very difficult. I just have to keep track of my numbers in my math. And the example with the gum gives you a sense of, okay, I can do the gum. I can figure out what part of the gum is actually a sugar. I simply now apply that to the use of elements and the percentage of those elements in compounds. That's our presentation for today.